आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello students, so question is given that given Sn is 1 plus q square, it is going up to q to the power n, and another Sn is given 1 plus q plus 1 by 2 q plus 1 by 3, like this it is going up to q plus 1 to the power n divided by 2. Now we have to prove that n plus 1 c1 n plus 1 c1 s1 into n plus 1 c s3, this is the multiplication of things. Now we will go one by one. First of all, we know that this series is what? This series is geometric series, and we know the summation of geometric series equals to how much? A into 1 minus r to the power n divided by 1 minus of r, isn't it? Now here the 1a is what? First term will be 1 minus r, you can find out q square divided q will be q, so q to the power, it is going up to n, so it will be up to n plus of 1, because 1 is also given, so these are n plus 1 terms, 1 minus of q. Okay, these are the summation of the what? Summation of your geometric progression. Now you have to understand one by one. You know, I can write these terms n plus c1 into s0 n plus 1 c2 s1 like this. So if I want to express this term in terms of summation, so I can write r equals to 1 to, it is going up to what? N plus 1, n plus 1. Now you can observe n plus 1 c1, n plus 1 c2 like this. So I can write n plus 1 c r into s of r minus 1, because it is not starting from first term, it is starting from second term, so I can reduce one term from here itself. Okay, now we will solve this summation part. Okay, now again what I can write, if I want to solve this summation part, so summation part is given summation of r equals to 1 to n plus 1 n plus 1 c r. This is what? This is the summation of geometric progressions, and we have found that Sn equals to this one. So what I can do, I can replace at the place of n, I can write r minus 1 in these terms. So I can write at the place of these 1 minus q to the power r minus 1 plus 1 divided by 1 minus of q, isn't it? Now if I will solve it next further, it will become summation of r equals to 1 to n plus 1 n plus 1 cr 1 minus q to the power r divided by 1 minus of q, isn't it? So this is what? This is my new terms. I got it. Now what I can do, I can multiply this to this one and then this to this one. So I can write this summation of r equals to 1 to n plus 1 n plus 1 cr 1 divided by 1 minus of q. Okay, then again minus sign, summation of r equals to 1 to n plus 1 n plus 1 cr to the power r divided by 1 minus of q. Okay, what I did, I write 1 divided by 1 minus q and q to the power r divided by 1 minus of q. Now I can take 1 minus q as a outside of these both of them, so 1 divided by 1 minus of q I can take outside of the summation part. Okay, now I can apply summation of r equals to 1 to n plus 1 cr minus r equals to 1 to n plus 1 q to the power r into n plus 1 cr. Okay, now I will solve one by one. Now first of all 1 divided by 1 minus of q. Okay, so if I will apply this summation on this part, so it will become n plus 1 c1 plus n plus 1 c2 plus n plus 1 c3, it is going up to n plus 1 c n plus 1. Okay, minus minus sign. Now I can apply this also. So I can write n plus 1c1 into q, again minus n plus 1c, either I can write like this, c2 into q square, n plus 1c3 into q to the power 3, like this it is going up to n plus 1 terms. Okay, now again I can write, now these are what? These are the n numbers of the coefficient of summation of the coefficient of n terms, n plus 1 terms. So I can write directly 1 minus 1 divided by q. At the place of these terms I can write 2 to the power n plus 1, because we know the summation of n numbers of coefficients are 2 to the power n. Okay, and these are what? N plus 1 cq, n plus 1 c3, like this it is going up to. So I can write these things minus, this is nothing, this is the expansion of 1 plus q to the power n plus 1, isn't it? Okay, now I will solve this as well as, so I can write 1 divided by 1 minus of q. Okay, now this is, just imagine, this is our first equation. Now in questions already given that, just take, this is Sn 1 plus q plus 1 divided by 2 plus q plus 1 divided to the power 2, like this it is going, q plus 1 to the divided 2 to the power n. This is what? This is summation of n plus n terms. Again I can write at the place of 1 minus, this is the summation of Sn. If I apply the geometric progressions formula, so q plus 1 divided 2 is what? Common ratio to the power n plus 1, because it is going up to n plus 1, because 1 is also there, 1 minus q plus of 1 divided by 2. Okay, now I will solve these terms. If I will take LCM of 2 to the power n plus 1, so it will become 2 to the power n plus 1 minus q plus 1 to the power n plus 1. Okay, for this 2 minus of q plus of 1 and 2 to the power n. Okay, now this 2 to the power n and 2 to the power will get cancelled out, and from here you will get 2 to the power n plus 1 minus q plus 1 to the power n plus 1 divided by 2 to the power n and 1 minus of q, because 2 minus of q plus 1, it will become 1 minus of q. This is our second equation. Now if you will solve, now solving these equations, this is what? Now you can comparison this equation to, just this is equals to 1 minus q, there is 1 minus q. Here 2 to the power n plus 1, there is 2 to the power n plus 1, and there is 1 plus q to the power n plus 1. So this is the same, and q to the power n is in extra terms. So what is this? What is these terms? So at the place of these terms, at the place of these terms, you can directly write this one, and this is equals to what? This is equals to what? This is equals to nothing, n plus 1 c1, n plus 1 c2 s2, n plus 1 c3, like that. So at the place of these I can directly write n plus 1 c1, n plus 1 c2 s1, n plus 1 c3 s3 s2, like this it is going up to, and this is equal, this will be equals to how much? 2 to the power n. This is what? This is 2 to the power n. 2 to the power will get multiplied to it, 2 to the power n into Sn. Okay, so this is your answer. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।